Hello. All right. Let's get things set up. I just hear like a little clicking noise. So I want to make sure that that's just in my headphones and not for you guys. So give me a second or two. We're going to get started very shortly. Yeah, the audio sounds really bad. All right, let me see if I can fix that before we get started. Testing. Testing 1, 2, 3. All right, that sounds a lot better. Nope. Okay, let's try this one last thing. Still getting like a weird glitch. All right, we're gonna get started shortly. Let me I'm just gonna unplug the mic and replug it in. Testing. All right, well, I can't seem to get rid of that little humming. That's annoying. But I wonder what's causing that humming. Okay, whatever. We're gonna power through it, and hopefully if it's too annoying, I can try to fix something. So what are we gonna be building here? First off, I need to mute this, and I'm gonna put my own audio on, and then hopefully. Yeah, I really need to figure out what that feedback is. All right. Let's get started recording. So, what have I been working on? I have a new build of PixelVision 8 and a whole bunch of other stuff. And our goals for today are we're gonna finish up some work that we were doing on Reaper Boy by cleaning up the pixel art, and then we're gonna try to build out. We're gonna port the Nest demo I built earlier in the week over to C#. So let's copy this version of the game creator over. As you can see, I think the last build we were working on was 704, and now I'm at 731. I've been spending some nights trying to just get this thing cleaned up a little bit better, and let's open this up and we'll take a look at sort of where we were yesterday, or actually I didn't stream yesterday, it was the previous day. So what I was working on was trying to get the graphics cleaned up. I think this one still has the bad graphic issues. So wherever there's transparency, the sprite builder wasn't putting transparent sprites where they needed to be. You can see this here by the little graphic at the end of Boy. You see it's just showing that weird repeating tile. And so what we're going to do is we're going to go back in and clean this up. And what I was actually thinking of doing was I've actually fixed the bugs. Let's just try to do a quick look and see if I just rebuild. Let me go into the sprites here. If I rebuild the sprites, if this new fix should work. What I discovered, yeah, there we go. Look, that's already gone, and now let's die. Whoops. By dying, I mean let's not like get killed by let's not kill the first bad guy. Oh, come on. I'm just so good at this game. Oh no. This is, if you've not seen this game before, this is a little game that I wrote called Reaper Boy, and I wrote this with Cass Pixel. She did the artwork, and as you can see, okay, all the graphic glitches seem to have gone away. What I want to do is try to let the guy die so that I can restart the game. But basically, I wrote this for Ludum Dare in, I think I did 72 hours. 48 hours is like way too hard to build a game. Oh, cool. Everything looks like it's fixed. So I did fix the bugs that we were running into last time with the sprite builder. So I think this is in a pretty good place. What we're going to do is I just want to clean up the rest of this game and get this sort of ready that other people can sort of take a look at the source and play around with it on their own. So what the bugs that we were running into were really around the sprite builder and whether it was able to detect sprites with transparent pixels. So this all seems to be working well. The tile map should be rendering out correctly now. We removed a few of the little like background guys to lower the sprite count, and I think there was something that I did want to add in. I'm probably not going to build it into this version right now, but what I wanted to make sure was that our tile map. All right, we truncated the tile map, which is good. In the resources folder, I had some additional artwork, screenshots. These were the screenshots I used from Ludum Dare. I was trying to get that like rounded corner thing that they used to have on the old Game Boy games. Those are the screenshot PSD. I was going to delete a lot of this stuff. I only wanted to keep the stuff that really mattered. But one thing that I took out that I wanted to put back in was there was an extra bad guy, and I'm not going to program the bad guy today, but I just want to make sure that it's at least in there. Where's our sprites PNG? Here we go. So we'll put back in this one. There were like two graphic sets that I pulled out that I will eventually want to go back in and fix. Let's copy these over and paste them down. And this was like a medium-sized enemy, which I never implemented, and some spikes. And I think that should do it for right now. Let's shrink this. Now, because I updated this, let me... we got to go back into the sprite builder and we got to rebuild all the sprites. So, yeah, we still have lots of room for sprites. So let me rebuild the sprite builder and just make sure that everything just runs. We'll go through one round of the game, and then I was going to take a look at the source code, and what we'll do to sort of to warm up is just clean up the code a little bit. And my plan is to, well, one, I have a whole new set of artwork for this game that I'm going to rebuild it. What I've been trying to do is just clean up the code and just make sure that, one, other people can like sort of play around with this game and get a sense of how I built out like a Game Boy style game in PixelVision 8. And then eventually what we're going to do is we're going to add like leaderboards and all kinds of stuff. We're going to implement all the new Amazon Game On services to this game. What I have to do is just get this thing sort of cleaned up enough that we can do that. And today we're just going to spend some time just cleaning up some projects of mine in PixelVision 8 so that they're ready for to be modified for using the new Amazon Game On services. And those really are going to allow us to do leaderboards, and we can run contests and have user-generated contests and some pretty cool stuff too. Now, I'm noticing one thing here. There's an error with the star on the splash screen. Let's go take a look at why that error is happening. I'm missing a sprite here. I wonder why I'm missing that sprite. So I'm going to pull up the tile map real quick, and let's just make sure that this is... Well, that's the correct sprite. So that's interesting. I wonder... Finding the sprite's not going to be impossible, but it's definitely going to be a challenge. I wonder where... that sprite is and why it is not being parsed correctly. Oh, it's right here. So this is 254. 254. That's interesting that didn't get parsed. Wonder if there's anything else that we're subtly missing. We'll just sort of skim through this real quick and just see if there's any. Or if you're just joining me, I'm just doing some pixel art cleanup. We'll do some code cleanup, and then we're gonna move over to taking a Lua game and porting it to C#, which should be an interesting little exercise. All right, let's save this out and reload it and make sure that this image is... All right, so this image is now being correctly loaded. Great. I don't know, maybe something weird just happened, but let's run the game. And all right, the artwork looks good. One thing I want to do is let's just do the death scene. I just want to make sure there's no problems with that. The skull. Cool. All right, so this game is pretty good right now. I think it's in a good place. We have a simplified font. We've compressed all the artwork. The last thing we're going to do real quick, let's not save this. Let's close this out. Don't save this. And I'm going to quit out of Photoshop for right now. What I wanted to do was I'm going to compress the sprites. And when PixelVision 8 compresses sprites, it basically just takes like, this is the raw sheet that I use. And when PixelVision 8 loads up, it goes through and it just sort of like parses out the data and turns each 8x8 tile into a sprite. It's really good about finding duplicates and removing duplicate sprites. So in this case, what it's done is I've just outputted what the sprite RAM looks like. And you might notice that this isn't gray versus this green. And oh, that's one thing we were going to do. We'll add that in today. What I wanted to do is add something where if you like hit up, down, left, or right, we'll change out the palette colors. I sort of wanted to test that out anyways. I thought that'd be a neat little trick like the original Game Boy Color. So right now, what you're seeing is it's just outputting the raw sprite data. And this is an optimized format. And then this will help load. I mean, you can't really see it. These aren't a lot of sprites in the Game Boy template, but this loads up pretty quick. And the only other thing we're going to do is we're going to create a compressed version of the tile map. And that's just a JSON file. And if we open up Tiled, I can sort of show you how that works. Here we'll go to our workspace sandbox, which is where our PixelVision 8 keeps the current game you're working on. We'll open up this tile map JSON, and now you'll see all of the tiles from the tile map, and we also have an extra layer for flags, which we use for collision. That grid is a little garish. I don't know how to. Oops. I don't know how to hide that grid, but anyway, so PixelVision 8 will also export out a tiled compatible JSON file, and now the game should just load like really fast. If we rerun this, it takes a while for it to render out the tile map in memory here. That's just the PixelVision 8 thing. But and we can go through and we can render out the tile map flag stuff as well, so you can see the collision flags. And once these layers are rendered, switching between them is pretty easy. And I just wanted to make sure the one thing that we haven't done is cool. So this game doesn't use any palette shifting. It just has the 4 Game Boy colors. And what I'm going to do first is let's go ahead. We're going to save out. Actually, what I want to take a look at is the name of this version data. Is this Reaper Boy? All right, we're going to leave this as. I'm going to call this Reaper Boy V2. And we'll just say this is version 2. I'm going to lock the specs down because I don't want to be able to change all this. One thing we should do, the draw calls, I believe the Game Boy only had... Let me save this for a second. How many draw calls did the... Maximum had 40 draw calls. So it looks like I've been changing some things around. So let's make sure that we use the limitation of 40 draw calls. I wanted this game to sort of match as closely as possible to like a Game Boy. And oh, we'll lock the specs too. Now, if you set the draw calls to 0, then you could have as many sprites on the screen as you want. I'm just going to run through the game real quick and just see if this affects anything. Oops, well, I died, so that didn't help much. So something, I did notice something is broken right now, and that is it's not recognizing the tiles correctly, the collision tiles. So I'll have to go back in and fix that. I'm just going to play this real quick. I just want to see if the last boss works. Like I'm not seeing, so what you notice like on a regular like Nintendo or a Game Boy game is that if you drew too many sprites to the screen, some of them would disappear. So I just want to make sure like when we have bad guys and clouds and all this other stuff that we're not actually eating into our draw calls. Let's take a look at the boss. Yeah, okay, so this is an interesting little problem that we have here. What's going on is the collision flags are rendering out as different colors for the tile map versus the tile map flag PNG. All right, why is that happening? Like, okay, it's hard to explain, but there's I use a PNG file that has all the flag colors, and there's like 16 colors you can use. I want to see something real quick. If I delete the tile map JSON file, and if I rerun the game, if the guy spawns in the correct place, there might be a... Nope. Okay, it just got corrupted. That's all. All right, I can fix that. What we just want to make sure is... Let me go to the tile map. We're going to create a new thing. I think I just changed some stuff in the code, so I'll just go back and just fix it. I did a new build of PixelVision 8 the past 2 nights. So I think I fixed some bugs that were causing me trouble before. So what we want to do is we just want to make sure that this flag, which is 13, is what we're actually looking for. I use collision flags for like so the 0 collision flag means that this is solid. 2 means that it's the door. This should be the oops. Yeah, sure, whatever. You can have my password. Anything else you need, like my social security number? And then these should be the spawn points, 13. And then the boss guy... oh, and these spawn points here are for bad guys, so that's 8. And then there should be one... I don't remember where the boss battle is. Here we go. So the boss flag is 9. So I just need to come back in here and we'll look at the scene game, and we're just going to make sure that we had these correct. So flag 2 is our exit. Flag 9 now is our boss. I don't know what this flag is. I'm gonna get rid of this line of code. Hopefully it doesn't break anything. And then what we need is the spawn point, which is flag 13. All right, so I did fix this. The other day, I wound up changing these numbers because there's something that was corrupted in the PNG output, but now everything seems to be fine. All right, so to sort of illustrate this, if we rerun the game, you'll see the player will now spawn at the platform, or at least where the exit is, versus like there was a generic, if it couldn't find that spawn point for some reason, it would, of course now we're getting all of the doors that are on the left-hand side, but it would just try to randomly pick a place and spawn the player in. what we're really looking for to see, okay, there we go. So now it actually works. So what we're looking to see is to make sure that that the boss spawns where he needs to, and that the game is completable. There's a lot that I want to do to this game. CastPixel created some like really amazing new art for this. I might have it on my computer. On this account. I'll take a look. So we do have the boss. We still have enough sprites. We're not running out of sprite count. And then there we go. So now we're able to win the game. Game is over, and we have a full game. The only thing I need to test real quick is the top of his head supposed to be disappearing on a jump. No, it's not. Let's see. Maybe we ran out of some sprites. Let's take a look. That's a good catch. The little bowl. Thank you. Let me, oops. And I think we got a corruption here. I thought I just saw the score when I replayed the game in the level transition. So we might have a few little bugs to fix. Did the score... Yeah, the score leaked over. Okay, so we can fix that. Let's see. Where was the boss? I've gotten like really good at this game. I was saying the other day, like I watched somebody try to play this on YouTube, and they were having like a really tough time. It seems so intuitive to me after I've played it for like a million times. Wait, what part of his head disappears? The top of his head is supposed to be disappearing on a jump. Oh wait, oh the Reaper guy? Yeah, it's just a flat little his face, he moves his head up so it looks flat. All right. So for some reason the score isn't clearing correctly. All right, I'm going to make that up. I'm going to add that as a bug real quick. Score is not clearing level screens. What else do we need to do? Remove the artwork back into the project. Add the Game Boy Color System palette. That's what we're going to do next. Is reduce the file size of the PV8 project. All right, so let's do this. We're gonna I'm gonna make a backup real quick, and then we're gonna start ripping out stuff that we don't need. I just want to make sure that whatever's in the game is exactly what people need. So I saved this as whoops. This should now be Reaper Boy V2, and we're gonna just archive that guy. Now I'm going to go through the files here and just make sure there isn't anything that we don't need in here. Default font, entries, flags, info, music, resources. So I am most likely going to delete the resources. We don't really need this. There's also a saves file, which I'll leave. I don't think I'm even using anything in saves. I could actually save out the high score and stuff. Maybe we should add that in there. Save high score to save.json file. All these different scenes are there. Sounds, sprite builder. We will leave the sprite builder. Well, maybe for this game I can get rid of the sprite builder. Sprite cache, sprites, tasks. So I definitely don't want to share my tasks. Tile map. I'm trying to decide if I want to get rid of the sprite builder. Basically, the sprite builder allows you, since you have to work in 8x8 sprites, this allows you to put like a larger PNG in a folder, and then the sprite builder goes through and matches them up. I am going to leave that in. That's a good. That should be a good enough reference for anyone who wants to see how this game is. Let's see, how big is this game now? So it's 406K on disk. I took out the size limit, but if we were to like right now, if I was to copy out just the critical pieces, color map, default font, we don't need the flags, tile map JSON. If I was to copy this, let me just make a new folder here called test. I just want to see how big this game actually is. All right, so the game is 160K. So I have to add back in, there is a limit. Well, there was. Oops, I opened up the wrong thing. Some of the constraints are that you can actually like give it a maximum size, which would just represent like what you could fit on a cartridge. But what I have to rework and what I've not been happy with is how I actually calculate that, because in your game folder, wait, how big did I say this was? 160. All right, that's fine. I'll move this to the trash. The hardest thing is I have to actually calculate all this stuff without taking into account like the sprite builder folder, or if you have sprite cache, ignore the sprites file and the tile map. So there's a few things I need to do. Also, like when I export out, you know, let me, I'm gonna write some bugs real quick just so I remember to go back and fix this stuff. But GitHub, I'll file these for like the future versions, but game creator, there were two things that I want to do. So the way that I've been using GitHub now is I file like every bug that I have. Like right now, I file every bug and also every task that I want, and I break them down by if we take a look at it, I set up like milestones of like what I want to do. Here you can see I'm 6 days late, only because I've been spending some extra time cleaning things up for the next beta release. And then I go through and I have all of my issues here. So like in this case, here's a clean up Reaper Boy. And I have some tasks in here. So I removed any files that are not critical for the game. And once I'm done, I can close this stuff out. I did want to add a new issue though. Add back in max game size support. Need a way to limit the size of a game based on the files that not everything inside of the sandbox folder. This should be tied into the export.pv8 process, which should only generate a zip with the core files when doing a build. All right, I'm gonna assign this as a it's a bug because it's not working anymore, and I'm gonna put this milestone into the next release, and we'll sort that out later. There's one other thing I wanted to do is export compressed PV8 file. When doing a build, need to generate out a compressed PV8 file in the root of the game build folder that only contains files needed. Tie this into the what are we tying this into? Into the size limit. So there's an export. This is an enhancement. This is a there is a way for PixelVision 8 to actually output. I could do a build. So like right now, I don't have all the runners installed. A runner would be like for each platform. But if I was to click build, What's going to happen is it's going to create a builds folder in the workspace, and here you see Reaper Boy V2, and it's going to generate out this PV8 file. And let's just take a look at this real quick. I just want to see if this is already doing this. Use zip. So all you need to do is you can convert a PV8 file into a zip and then just unzip it like you would anything else. Yeah. So here you can see I'm including this sprite builder and this other stuff. It shouldn't include any of this stuff. So here you can see that the game is at 255K, which was my limit, 256K. So it would technically compile. I'm using air quotes, which you can't see. But what we'd want to do is, let's say this thing should only output, like it wouldn't need this or this. Sprites, it wouldn't need this or this or this. Move to trash. Just making sure that all these files are correct. And then, right, so the final size of this game is 184K. Why is it 184K? Is that because I included the tile offset at 15K? That's fine. And then if we were to zip this guy up, it compresses down to 35K. I mean, none of this stuff really matters. This is more for if you're trying to build out, if you're trying to keep this authentic to like a Game Boy, this would be like I don't know, like 126K for like the early ROMs. Also, you can see it outputs a WebGL. I think in future builds I'm going to actually ditch WebGL. As convenient as it is, it's super buggy. This relies on Unity's WebGL output, and it's just really bad. I did want to see. I don't think I had this installed here. Let me services, new terminal at folder, npm. Do I have npm installed? Hey, look at that. HTTP server. Hey, look, that actually carried over from my other user. All right, so I'm running an HTTP server in here, and this is going to make noise, so this might be a little loud. Sorry ahead of time. But let's go to like local host and do 8080. And it should boot up the game. It just takes a long time. This is the problem. Sorry if that was really loud. I gotta change the boot up volume. Oh, and then it's gonna play the song. There we go. And then for the most part, it runs okay in the browser. I think what I want to focus on is more like desktop publishing, just simply because like as cool as it is to have the web build, I'm not very happy with the way that it performs, and that has more to do with well, a lot of things. One, it's Unity. Unity's WebGL build is like not very good, and then two, it's also running like a Lua VM on top of everything. So it's like Lua VM in C# on top of a WebGL, ASM, compile, magic, whatever they do. I mean, it runs. I don't know. We'll see. I'll keep it in as like experimental. The other thing I was going to say is like if you had other runners, which you can download from the PixelVision 8 site, it will give you like Mac, PC, Linux, and give you different builds. I don't have them installed right now, so cool. All right, I think well, that's pretty cool to know that Node works on here. All right, so this is now optimized. I don't think I'm going to do much commenting. I've gone through and I think the only commenting I wanted to do for this game was, let me pull open in here. I'm going to add some comments. So this is PixelVision 8. We're going to call this Reaper Boy V2. And let's see. I don't need to have this. Well, this will learn more about making PixelVision games at HTTP PixelVision 8. I have a new site that I'm going to be launching maybe tomorrow. So I don't have a license for this. I should probably just find a where do I put my other licenses? I have hold on, let me find what. Oh, you know what? I think it's in Game Creator. System libs. Demos. What did I put the license for these guys? I didn't even put a license to it. I have a I should probably put some license on this stuff. There's what I've been using for PixelVision 8 is the is a Microsoft license, ironically enough, but I picked it because it where's the SDK? This where was it? I just lost it. This is licensed under Microsoft's public license. The reason I chose this license is because it it actually lets you it's still open source like MIT, but it allows you to retain hold on, let's look it up real quick. I am by no means I'm not a lawyer. But what it did do is it allows you to do reproduction, derivative work. I think you're just not allowed to use marks. Grants of right, condition limitation, no trademark license. This license does not grant you the rights to use any contributor's name, logo, or trademarks. Right, so you can't, you can do whatever you want with PixelVision 8 or any of the source code. You're just not allowed to use the any of the names of the people who contribute to it, our logo, or any of the trademarks that we have for it, which we don't have any trademarks, but whatever. And then like regular patent stuff and as is. So that's the license that I've been. That's the license that I've been using. So we're gonna add this basically to all the code files, and then that should just cover it. I think I did like a decent enough job of just sort of commenting some of this. This is a very complicated project. I'm probably gonna do like a tutorial or a book or something on how to build this game. But all right, so this one goes to Matt. Code, data, entities. All right, so what I've done is I've broken out each of the I made some like simple objects. A lot of this stuff I'm going to clean up. I'm probably going to just rebuild the whole game from scratch, but for the most part it's more for just learning. I'm trying to take out like anywhere where I see like just big blocks of commented out code. This won't be perfect. As I continue to work on this game, I'll clean up more and more of it. So I can actually make little code modules in PixelVision 8, and you can load in other Lua files. So here there's a dependency. So I have a custom method called load script, which sort of helps with the sandbox of running the Lua stuff on C#. And what happens is it just pulls in this micro platform, which is the modification of Matt Hewson's micro platformer that he made for Pico 8, and then we ported over to PixelVision 8. And then like entities, so I can pull in different entities. So, all right, that's good. Let's do the level scenes. So each scene in the game is its own little object. Copyright. All right, scene over. Splash scene. I'm going to skim through these real quick, and I'll just make sure that there's no color offset, time map, JSON. Okay, let's make sure there's no like big blocks of code. I mean, when you build a game in a game jam, like there's like all kinds of stuff that you probably. I'm going to leave that method. I'm just going to it seems like that's commented out, so I'm not going to do anything with it. Scene level. All right, don't need that. I'm just trying to take out all my to-dos. The game scene is pretty massive, though. There's a lot of logic in here. Excuse me. All right, that looks good. What else do we have? Entities. There was nothing else. I think I already got rid of the stuff in the entities. And then that should just be, oh, we can get rid of that. That'll just be the like high level cleaning up this this code. Before I close out the Pomodoro, which I already see that I'm a little bit, make sure you delete this item. Yeah, I don't need that. The only thing, oh, what we should do is let's, I just want to get a copy of show package contents of the license and put that at the root. Resources, data, streaming assets, system, game creator. Do I not have hidden files shown by default? Let's fix that. Hi, Sierra, show hidden files. All right, let's see if I can actually do this without blowing up my my recording. Testing. Testing. Hey, I still got sound. Okay. Let's see if this shows us hidden files now. Nope. All right, I'll deal with that later. What was the since releasing find is now possible to use this shortcut. Command Shift plus. Whoops. Show hide. Why is this? Press return. Hold Option Alt and then right click and relaunch the Finder. Why is this not working the way that I expect it to? Games. All right, whatever. I'll just download the license from the GitHub repo. Let me get the raw file. And we'll just put this in workspace, sandbox. So at least now there's a license for using the game. Did I not save that to? Oh, here's sandbox. Perfect. All right, it saved the license. That's all we really need. Do I prefer Mac over Windows? I go back and forth. I had like a few years where I was on Windows. Now I'm back on Mac. You know, it all really depends. Lately, I've been leaning more towards Mac. All right, I think this is done. You know, it all depends on how I feel at the moment. All right, so what I want to do is let's refresh this. I'm just going to rerun the game. Let's just do one round through the game, sort of test things out and make sure I didn't break anything by deleting the files. And then what I want to do is just figure out how to clear that. I don't know why I wasn't able to clear that that high score. I also need to close out this Pomodoro. So if you're just tuning in, we're just cleaning up this game real quick. And then I'm going to switch over to, I wrote this little demo in Pixel Vision 8 that sort of shows off how you can do like nest style sprites, where basically like think of like Mega Man, where there's like 4 sprites, and then the 5th sprite had the actual like color for his face. It's a way to get around the color limitations of the Nintendo, which only allowed you to display 3 colors per sprite. So what I wanted to do was I'm going to port that from Lua to C#, and I think that's the last demo. We'll fix this little score bug, which is annoying. I really wish I knew what was causing that score. Oh, I want to die. If you build up too much speed and hit the ground, it like eats your score up, and then it winds up killing you. Score. All right, so I just want to make sure all these screens work. Everything works. All right, we just got that high score bug to fix. Oops. No, let's not quit this. All right, so I'm going to close up my Pomodoro. I'll take a second just to like stretch my legs. Score is not clearing between level screens. Oops, no, wait, we haven't fixed that. Save high score to add Game Boy Color. Move to our reduce file size. We've done that, more or less. All right, so I think that covers what we've done for the first 30 minutes or so of the stream. Just gonna take a quick stretch. I hate sitting, like I can't sit at the computer like for really long periods of time. Like it starts like just feeling really uncomfortable. So I just wanted to see there's just a few emails that are coming in for work. So I did I'm just making sure that we I just want to make sure that, well, this is part of my job as an evangelist, is to grow a user base of people who are interested in listening to development. I also can't like ignore my email all day long. It's been like my wife has been out of town, so I've been watching the kids for the past few days, and she's back in town. I think she just took them out for a play date. So I can I've cleared off this afternoon to sort of catch up on my Twitch stream, because the past few days it's been sort of irregular while she was out of town. All right. That being said, let's do this. I want to drink real quick of water, though whiskey would be nice right about now, and then we'll fix a few little bugs in Reaper Boy, and then we're going to move over to porting a Lua game over to C#, and I'll sort of show you what that process is like. I'll be right back. I'm just gonna mute this so you don't have to hear me sucking on a water bottle. All right, so I want to. I'm just gonna archive this real quick. All archiving does is it takes the project and it like zips it up, and then it puts it into our games folder, and that's sort of built into PixelVision 8. So here we should have a Reaper Boy. It says Reaper Boy V2. I do have like a bunch of different versions of them. In fact, what we should just do is let's just I'm just going to delete these other versions of it. I have a feeling like some of these won't delete because it doesn't have permission. We can just do it manually too. Sandbox games. Oh right, these are folders. I can't delete folders. I have to fix that at some point. We'll just move these to the trash. And then, all right, I'm going to go back in and let's just create a new archive for this. And so now if we went back into our games folder, we should see a Reaper Boy V2. So that's been archived. So what were the, we had two bugs that I want to address. Oh, I want to do the Game Boy Color stuff. I think that's kind of cool, but I do want to fix this scoring bug. So let's run a real quick test and just see if where that scoring comes from. I want to see if it's when you die and if you restart the game, if that score for some reason lingers. It definitely was the second time that we did the game best. All right, so it's only when we win the game. So that's not fun. One thing we could do is I just want to look at the level, the scene level, and just make sure. I think I was clearing it, but rebuild tile map. Draw text. Scene update. Here we draw the stars. Draw tiles. Clear area where the score is. That's supposed to clear the area where the score is. Let's go and take a look at what's really going on here. I think what we can do is I feel like I had a I thought I had some code in here that allowed me to do a debug to jump right into the it allowed me to jump to a different level so I can go just to the boss battle. I can't remember where I put that scene level. Level scene update draw. I don't remember where I was able to hack that. Let me let's poke around here for a second. Code. Scenes. So let's see what this thing does. When the splash screen resets, it rebuilds the tile map. It goes to screen 0. Background color 3, draw tiles, draw the logo to the U. That's a splash. I want to go to the level screen. We don't need this anymore. Each level you play, you get more points for completing it. Offset level bonus. This bonus level 13. If the level bonus is less than 5, go here. So I think if we I think we can just do this. Level equals 13. That will probably just get us right to the boss. Hey, Minor X Gaming, welcome to the stream. Yep, there we go, right to the boss. Perfect. All right, so let me just beat this boss, and then we're gonna try to figure out. I'm gonna take a screenshot. I just want to see where. Oops, I died. Let's restart this. All right, should be able to beat the game, and then we'll take a screenshot here of the score, and then there. Whoops. No. I gotta redo this. Sorry. This is one of those annoying bugs where you only see the bug after you replay the game, and that means you gotta, like, replay the game a lot. All right, so we'll take a screenshot here. what I'm trying to figure out is just where that row of score is, so I can make sure that when we start a new game, I clear that, and that they're actually lined up in the same place. So in Pixel Vision 8, you can just hit Control 2 in order to take a screenshot. So here we go. If we open these guys up in Photoshop, we'll see that the text is at the same place. What we just want to do is we just want to make sure that we clear out this entire row. So 3256. But I wonder what we could do is, let's see if we can just when this thing restarts, scene init 3256. I think my math was off here. Clear the area where the score is. Oh, that was the that's the score at the top of the screen. What I need to do is we need to figure out where we can That's really interesting. I wonder why that's there. Count up the stars to the next level. What we can do with the scene level is draw rect. It was 56. We're gonna have to offset this. I can't remember where the offset is, so we're gonna sort of eyeball this right now. But 56, 32 by 56. So 32, 56. The width is going to be 96. 96 and 8, and we're going to set this to -1, which will be the background color, and we're going to do draw mode tile map cache. But what we got to do one last thing. We got to take into account that I did a little trick in order for the backgrounds to work, and what I'm doing is, if we look at the tile map, it's actually offset by a certain, like each screen is just a different position in the background. So what we want to do is we got to offset this by 168 pixels. 168, and let's just add a comment here. Clearing high score from previous game. Let's see if this clears that, and we'll try it again. Sorry, Minorx Gaming, you're saying I'm also making a game. It's the last Robo, and doing AI and some enemy stuff. Really difficult. How about you? Well, what I'm doing is I'm just testing out. I had this game that I wrote for Ludum Dare. I've been cleaning it up so that I could share it with other people. And there we go. Okay, so it did wipe that area. It is not using the right color though. We'll fix that in a second. I just want to make sure that here it works fine, and I just want to say when we restart it that that mask is in the right place. Yeah, okay, so that works. So what we got to do is I just got to figure out which color is the right background color. I think I set the background color here. When this scene resets, don't I change the background color? Background color 3. So let's just make this 3 and then rerun it. So my goal is that once I get this game cleaned up, I'm going to start adding some of Amazon's new game services, Game On, to it. And I'm going to do, there goes my dog. Go get him, killer. I hear my dog downstairs. He sits at the window and he barks at other dogs that walk by. The dog is like 3 pounds wet, so he's not like really that scary. All right, it looks like I got to beat this game. I can't just die. It looks like this is now masking off that area correctly. And so I have like the very basics of like a high score in there, but eventually what we'll do is my goal is to make, whoops, I died. That's not good. My goal is to start using stuff where like people can actually compete, and I'm going to build a lot more levels and make this game a little bit harder. Although it is kind of hard right now for most people. I'm really good at it because I play it a lot in testing, as you can see. Let's see. So there's a score. We'll restart the game, and if the score is gone, our job is done here. Perfect. All right, so that fixed that bug. What we got to do is let's just remove this now, and I'm going to play the game. I'm going to play one full round of the game and just make sure that that score issue is gone. So Minorx Gaming, what game are you working on? So Last Robo. What are you building it in, and what are you looking to do with it? How are you going to release it? Guys, feel free to chat. I'm trying to get better at watching the chat window and being able to sort of respond. Whoops, I died. That's not good. Maybe I can't talk and play this game at the same time. Like a big part of what I went for with this game was I really wanted to capture that Game Boy aesthetic, and that's why I wrote Pixel Vision 8. Is if you're just new to the channel or you haven't heard me talk about it before, Pixel Vision 8 is I was growing really frustrated the way that Unity handled 2D games, especially like old retro style ones, and I wrote one. I think there's a link in the Twitch page for Dragon Sweeper. Which was like my last like real game. I got really frustrated after I built that game, and I started to build my own sort of fantasy game console. And it's taken me about 2 years, but I'm at the point now where I'm finally back on the stream. I'm able to start building games on it. As you can see, this is one of the games I built on it. And while I do sell the Game Creator Pro, which is just like the tooling for it, there is an open source version. We're going to take a look at that later and how that runs in Unity. But I wanted to build something that did exactly how I liked. I wanted something that worked exactly how I wanted to build 8-bit games. So that's what this game is built in. Cool. All right, that bug is fixed. We're good to go there. Let me open up this task. So score is clear between levels, and then what I wanted to do was for the game over, for scene over. There should be a game win. What I just wanted to see was where do I calculate the best score? And all right, so what I was doing right here was I was going through and calculating the best score. What I'm actually going to do is here you can see like if best score is nil, so I don't define best score anywhere. If it's nil, we're just going to set it to the user's current score. Just for right now, we're going to read best score from save file, and we'll do best score equals read save data. We're going to call this best score. And we're going to make the default value, I don't know, what, let's just make it 500 or something, right? Is that like a realistic score? Let me run the game and take a look. I think the game's, since the game is pretty limited in levels, I think there was like a certain amount of scoring you can do. Yeah, there we go. Okay, even if you get to level 3, you should be able to beat 500. There we go. All right, so we'll leave it at 500, and then what we'll do is if the I want to convert this to a number, and now what we're going to look for is to see if if score is greater than best score, which I need to spell correctly. If it's greater than best score, then and we're going to set best score equal to score, and we're going to write save data best score to string score. And we can now get rid of this here. And what should happen is if we rerun the game and we're going to die in the first round, it's going to immediately make the score 500. And what we should see is that until you actually beat 500, there you go. So the score was automatically defaulted to 500. Let's beat the game real quick, and then it should save the score. And then I'll show you sort of how saving works. I came up with, I'm super proud of myself for this. I came up with this really clever system for saving. Now, a big part of building Pixel Vision 8 games is the idea that you can like zip it up as a PV8 file and then share it with others. But there's one thing that like I really loved from game consoles, and it's like from cartridges, was the idea like if you got a cartridge from a friend, it had like all their save data on it. So what I did was I built a save system where if you share the game, it saves it into the game. It saves the score into the game itself, or any save data. So you can actually share a PV8 file, and it'll still have all the save data from that person. So here we go. We see the score was calculated. It's better than the best score. And I'm going to exit this real quick. And let's just go and take a look at the save file. And if we look in here, you'll see the best score is now 1668, which is exactly what it was before. If we save this, obviously, if you wanted to like make this a little bit more protected, you could write some sort of like some sort of way of obscuring that data. I'm going to kill the guy, and I just want to see if the score should be like 16, whatever it was. There we go. So it's still 1668, right? If I stop the game and let's quit out of the text editor and rerun it, we'll see that the score should be exactly the same. And it's just brilliant. Like, I don't know. I think it's brilliant because now if I was to like it makes each cartridge or each PV8 file very unique. Even though it's the same game, there could be multiple ones floating around that have different people's like high score and their data in it. And I don't know. I think that's cool. Anyways, that's my little personal touch that I added to the engine. And there's like a lot of little details that I've written in the Pixel Vision 8 that, you know, Unity's a really good game engine for the most part. It's just, it's so expansive in what you can do with it that I really wanted to like, I love building Nintendo style games, and I wanted to make sure I had something that worked perfectly for that particular use case. So that being said, the next thing I wanted to do was oh, here, let's see. Minor X Gamer was saying here, gonna release this game on Newground. The last one was about a human get extinct, and they have an AI robot to collect data for the new evolution instead of aliens coming to Earth to find any humanity, but find an AI robot, and the aliens try to reprogram the AI, but it malfunctions, kills everything in sight. That sounds like a fun little game. What are you building the game in? All right, so this is good. I want to, I'm going to archive this and just save a new copy of it. And now I wanted to do one little thing for fun. And then we're going to move on to taking a Lua game and porting it, a Lua Pixel Vision 8 game and porting it to C#. What I wanted to see was so video game system palettes. All right, so what I wanted to see was, this is the palette combo from oh, that's an interesting little matrix. All right, so these are all the different Game Boy Color palettes that you could support. And one of the things I wanted to show off that's kind of fun with Pixel Vision 8 is that you can like rewrite the system colors on the fly. So what I was going to do is, let's we're going to implement each of these palettes, and I'll sort of show how they work. So if I'm reading this correctly, the following shows the startup palettes, background plus both sprite planes. The combination of colors used, the name is taken from the Game Boy Colors manual. The colors are simulated. All right, so let's stencil. Wish you could afford Game Maker 2, but stencil is the cheapest. Yeah. Well, if you use Game Maker 2, you could. We worked with Game Maker to support. There's a 60-day free trial for Fire OS, so you can, if you build something in Game Maker 2, I think that they have a free version, right? But then it's like, I think if you're publishing, you can use a 60-day free trial and you can get it onto the Amazon App Store and Fire TV, so maybe worth checking out. I've known a few people make some games in Stencil. It's not a bad little platform. I've never used it myself, but I've heard some good things about it. All right, so what I wanted to do was, we're going to when we load up the game, we're going to change the palette. And let's add in a little logic here, and we'll see how easy we're going to make this. First, what we're going to try to do is, let's just see if we can get to read the right key combinations, and we're going to map them. So let's see, switch. Well, what we'll do is set system colors, and we're going to create a new function here called set system colors, and look to see what key combination is pressed. So first off, what we're going to do is, do you know any full free engines I could use? I don't know any full free game engines. I mean, well, I think, isn't Go, I forget what it's called, Go Game Engine? Now I can't remember, I'm mixing it up with, no, wait, what, hold on. I don't know, there's another, there was another free game engine, I can't remember what it's called, but, will there be Super Game Boy Enhanced palettes where there was a palette for the background and 2 palettes for the sprites? Nah, I'm not going to do that. I just thought it would be a little fun. One thing I haven't tested yet, I mean, a big part of, like, there's twofold, right? Like, I'm writing these games because I need some demo games to show off as doing my evangelist duties for Amazon. I need some games to show off building games that use the Game On APIs. So right now, none of my games are really set up for that, and that's why I'm trying to clean them up. And then the other part is I also use this to test my game engine because I want to be able to support the open source game engine I've been writing and get other people to build games on it. So one thing I haven't tested yet is really switching out system colors at runtime. So I think it's something that I want to take a look into. Let's do this. First off, let's look at local direction. And what we're going to do is we're going to set this to nil. And we're going to see if button. We're going to look for button 0. I don't want release. I have to look up my own git book, Pixel Vision 8. I can't remember the APIs for the button stuff. I have to, it's been on my list to like rewrite the input stuff. Input, button, state. Where are the states? The state enums. Button up, input state down. So 0 should be default. Okay. I think we could just get away with this. So what I'm thinking of doing is we're going to treat this as a matrix, right? Like, let's take a look at this here real quick. What should happen is that we're going to set a value for up, down, left, and right. So that'll be 0, 1, 2, or 3. And then if the A button is down, we're going to add 4 to it. And if the B button is down, we're going to add 8 to it. And then we'll set up the colors, and that should shift the colors correctly. I'll sort of show you what I'm talking about, how this will work. So if button down equals true, then we're just going to set direction to equal. We'll do 1 because everything in Lua is 1 base, which I find like super annoying. Else if button 1 is true, we'll do direction equals 2. And what I just need to make sure is that I'm doing this in the right order. So up, down, left, right. Perfect. And then let's just copy this. And this will be button 2. We'll make this 3, 4, and make this 5. 1, 2, 3, 4. I messed this up. This should be 3, and this should be 4. Okay. Then what we need to do is see local button equals nil. Actually, what we should do is I can't remember on the Game Boy, did you have to hold down up and A to get here? You couldn't just hold down A, right? Game Boy manual. These names were taken from the Game Boy user manual. Let's see here. Game Boy manual. All right, using the Game Boy Color video system. Changing the screen color. Okay, here we go. So up. Yeah, okay, you did have to hold down. You can't just hold down A. It has to be up or up plus A is red, brown. This only worked with the original Game Boy monochromatic games. The color cannot be changed if the game title appears. All right, so that's what we need to do. It was a combo. Perfect. Yeah, cool. We're doing good here. Let's copy this. And we'll paste this here. I'm willing to bet this is exactly how it did it in memory too, or on the actual Game Boy. Like it just shifted some sort of matrix, similar to how I'm going to do it right now. What was the other thing I need to see now? So A and B, so 4 and 5. So we need to just test out 4, 5. So this will be 1 and 2, and then we'll multiply it by the total number of colors. So what I just want to do here is I'm just going to do print logging, and we're going to say color shift, and we'll do dir and then there's one thing I wanted to do real quick was tail log file. I can't remember what the command is for tail. There we go. All right, I'm just gonna output to the terminal. CD. Where did I put? tail this log file. And is it tail or cat? I can't remember. If I run this now, syntax error, line 57. Well, where is it where control the length of the tail, follow mode, filter with grep. Operators of the follow mode. Here the tail prints the final lines of a file, then watches for new additions at the end of the line. Oh yeah, let's do this. This is what I want. Tail dash F. And then I believe if I restart this, yeah, okay, there we go. So now it's just going to output the log file to the console, and now I just need to figure out this bug. So line 57. Oh yeah, cool, awesome. It's going to take a second for my brain to adjust to Lua. Then I have to readjust back to C#. 55. What did I do wrong here? Oh, you know what? Look at that. Wow, Jesse. You added semicolons. I've been doing a lot of C# dev. Lua is like a really weird language. It like really takes a while for my brain to adjust to it. All right, let's see if that now works. All right, so we see color shift got outputted and it's 0, 0. Now, if I'm going to, how am I going to do this? I got to, that didn't work. I got to, I'm trying to figure out, I got too many key combinations to do. Oh, that didn't seem to work. Why doesn't that work? I wonder if... let's do this. I'm just going to output this to the update statement. I have a strange feeling that... update. That the first round of it doesn't... it doesn't register when it's loading up on init. Yeah. All right, so that's working. All right, so what we're gonna do is we're gonna do a first run here. We're only gonna call this on the first run, and then. So I'm pretty sure that when the system loads in init, it hasn't gone through one cycle yet to understand the input. Like the input hasn't registered yet, so it doesn't work. Minor X Gaming is asking, where did I learn how to code? I am self-taught. I think I started coding around like 8 or 9 years old, and now I'm 38. So I've just been coding for a really long time. My background's actually in art. So I'm a self-taught coder, and I mean, I used to consider myself more of an artist, but now I definitely say at this point I'm more of a programmer than an artist. All right, so we're gonna work on this. Wait, why didn't this? Here we go. So log this Pomodoro. All right, so what we need to do is we're going to do this. Let's come here and if first run equals nil, then end. So here we'll call the system color, and then that should load up. And afterwards, we need to set this to false. So since Lua is unique where you can define a variable, or you can reference a variable that hasn't been defined, and it automatically returns nil, we can just use that to our advantage. And then after first run is set, we'll just set it to false. So now let's try restarting this again and see if we can catch this correctly. I think what I want to do is let me let's clear this screen. And now we're going to restart this. And as you can see, the first run, it now sets it to 1. And if I should actually like trace out the right stuff here. Direction and button. So one thing that was interesting is that it called it twice, which I don't know why it did that. Maybe I still have that in the init. Yeah, okay, I had it in the init. All right, so let's get rid of this. And we're just going to leave it here. So if I restart this now and I hold up, we should just get 1 and 0. Because of I have a poker 3 keyboard. I don't have arrow keys, so I have to use function key. Where's let me see. There's a way that I can set like function menu control and shift on the right side of the keyboard. Hold on, let me see. Poker, RGB, arrow key mode. My keyboard is not allowed a combination. There was a way to, hold on, Poker 3 RGB manual. There's like a secret mode at the end here that does, yeah, here we go. It's the left Windows key, right Alt, and spacebar. There we go. Now I can use the left key. I can use my left shift function menu and control key as a thing. This is a great keyboard, by the way. I don't know if anyone like is into mechanical keyboards. You can clearly hear it. RGB poker. It's just, as you can see, it doesn't have arrow keys. So, but I love it, and it's actually really cool. You use like I have a bunch of like key command stuff that makes it easy to use. But okay, so what was it? It was Windows Alt space. All right, I'll remember that or just look up the instructions later on. So now what I was trying to do, the reason I was doing that was I wanted to be able to restart the game and hold down. Why did that? Oh, I think that's because I set this to the direction. Here we go, button. All right, so we'll, whoops. We'll restart this and hold down C. And then what I wanted to do was we're going to skip 1 frame. Because if you just hold down X while the game loads up, it's going to go right into... well, I don't know. I'm not going to spend a terrible amount of time on it. The problem we have is that if you hold down X when it boots up, it goes right into the game. But there should be a way of... what it should be is... the game should only start when you hit the start key. So we need to add that as... I I need to remember that or I'm going to forget it. Let's write that down. All right, that'll fix that problem. Okay, so now we have all of the colors. Now there's two ways that we could do this. I could create a table of colors right now as hex, and then we just simply remap the first 4 colors, or I just set them in the color palette and then I shift them manually. I think the easiest thing to do is going to be I'm just going to write all the colors out by hand instead of putting them into the into a palette. Well, hold on. There's a color. There's a. I do have something here that lets you swap out colors. Input file. Display color. Method allows you to quickly change a color to an existing color without triggering a display chip to parse and cache a new hex value. So what we could do is we'll build them into a palette and then we'll use replace color to swap out colors from a separate color palette. So yeah, okay, this will work. This takes me a little time to figure out how I want to do this. All right, so we're gonna copy this image. And then we'll open up in Photoshop. Let's close this, and close this. And we need to look at the game's colors. And I want to set this to, the width is going to be 8 by 8. And the background color is going to be magenta. And we'll set up a new that was not the intended result. Okay, each one of those are individual images. So let's just take a screenshot of this. And close this, but we'll open up on the desktop our screenshots. So what we're going to do is there's 1, 2, 3, 4, 8, 9. 1, 2, 3, 4. We're going to set them all up as individual palettes, and we'll just do the math to figure out what their IDs are and do that. Okay, so all of these colors are going to all use black. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, 12. 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So in Pixel Vision 8, what you could basically do is there's a colors PNG file in your game. And all you have to do is, this is so cool. I'm like actually just like excited to do this because this is like a pretty interesting little trick. I might actually break this out into a demo and do that as a separate demo. So once we get this working here, I'll break this out into its own little demo. And then it's a neat little trick to show up how Pixel Vision 8 can remap colors on the fly. So yeah, once you set up this color PNG, basically it goes through and those are pretty close. I guess it's a little bit more red. And then it reads the colors from this PNG file, and those are the system colors you have access to. So in order to add new colors to the system, you can go in and do this by hand, but sometimes, like, because, like, going back to the question earlier, like, how did I learn how to code? Like, my background's in art. I wrote Pixel Vision 8 to have a more artistic workflow. So it favors like doing stuff in PNGs like this versus writing it out in hex code. So almost done. And then this one's inverted, right? So we start with white, yellow. I wonder what the reasoning is behind these colors and how they sort of did that. Okay, so these are the base colors. I'm going to save this out, and I just want to make sure that Pixel Vision 8 can actually display them. There we go. Those are all of our colors. You see it just loads it up pretty quickly. So now all we need to do is figure out where the start index is, which is 4, and then add the correct amount to it. So if we go back into our code here, the first thing we need to do is we're going to create a so local offset equals 0. And then before we do anything, all we're going to do is do 4. We're going to loop through 4 colors, and we're going to do how do we figure this out? We want to do swap. Does that API not come up? Oh, replace color. Replace color. Whoops. We're going to replace color. Why is this not? Oh my God. Adam's having a moment here where it can't. Replace color. I-1 with offset. So what we need to do is local index equals 0. Actually, we can just do this as 0, 3. Normally in Lua loops we start with 1 because it's 1 base, but since we're using an internal C# array under the hood, we can just do that. So we're going to replace 0 with offset plus, or then with I plus offset. Now I'm just going to rerun this, and the game should just run and look exactly like before. So now if I was to change the offset to 3 and save it, let's see if this even works. Ha! All right. Now what we need to do is figure out the math. So the offset is 0, and that's the default thing. So if I think what I want to do is this should be, the offset should be, let me see if 4 starts us at the right place. There we go. All right. Look at how cool that is. This actually is going to work pretty well. I like this. I like this little demo. All right. So what we need to do is, okay. So if, oh, I know what's going on. I'm using the right shift in order to, I got to disable that. Okay. I was using the right shift to do the parentheses, and then what was happening is that because it remapped it to up, it moved it up. So okay, so if offset, let's see it here. If direction does not equal nil, then the first thing that we need to do to the offset is this. we need to take direction equals direction multiplied by 4. Right? Like let's figure this out for a second. It would basically be, this is 1. So 1 plus 4 means that the offset starts at 4. If it's 2, 4 times 2 would be, it would start at 8. So that would be the first row. So let's, offset equals direction multiplied by 4. Right, because 0 is the default one. All right, let's rerun this now and see. And I'm going to hold down up. Rerun it, hold down. Left is blue. And right is green and red. So now there's, I think, I don't think the colors are right here. Oh, it is. Look at that. That's so garishly ugly. Would people actually really use this? So that was right. It's red, it's black, red, green, and white. Ugh. Terrible. So if I restart it again and I do down, that's going to be this pastel mix, which is black, purple, this pink, and that yellow. What does that game look like even like this? Whoa, is that super ugly? I mean, you got to understand, like, I didn't build the game to support this kind of color shifting, so like the artwork isn't going to look good. I mean, some of them it might look fine. This it definitely won't look good in. But it works. Look, like we're basically simulating what a Game Boy Color did. It just shifted over all the colors. And it's non-destructive. Like, we could actually do this at runtime if we really wanted to. This one might look a little better. Yeah, there we go. Blue looks good. Huh. So, while this is like a pretty simple thing in like theory, what's really what I find, like what I'm really impressed with, if I could like pat myself on the back, is like it took me 2 years to build this little game engine and to do something like super simple like this, but the whole goal of this game engine really is to capture that, like, the beauty of like these old consoles, and just to be able to do something like what the Game Boy originally did so quickly is awesome. So I'm super happy. Let's do this. So now, if button does not equal nil, then we're going to take the offset equals offset plus the button value multiplied by 4. And that should give us the rest of the matrix. Because, let me double check that. Let's see. So what's a color combination? So if we want to get to red, we need to do up and A. I have to switch back over to this. So if we control up and A. All right, so that's red and purple. I think my math is off. Like if we did up and B, doesn't like. Am I not adding this correctly? Let's see here. Ugh. Maybe we'll set this to 0. No. I gotta think. How do we get to the next row? Because if we let's just think this through. If we do up, it's going to set it to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. No. 4, 5, 6, 7, 8, 9, 10, 11. Why is this off by 1? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this should be 20. So let's just output that this thing starts at the right place. Right? Because if we did this as a proper matrix, it would look like it would start at 3, right? 0, 1, 2, 3. So 4, 5, 6, 7, 8. So 4, 8, 9, 10, 11, 12. Right? 0. Am I doing this math right? We can just do it here. 4, 8, 12. So 4, 8, 12, 16. $20, 24, 28. 20, 24, 28, 32. And then the next set of matrix values would be 36, 40, 36, 40, 44, 48, 48, right? And now if we come back here into Photoshop and we, let me just shrink this real quick. I'll just write these down. This is, whoops, hold on, I gotta disable, excuse me. So this is up. Oh, that stinks. It's not going to... So that's just up, down, left, right. And then this is... But why do you need the color chart to count by 4? No, I'm just writing the map. I'm just writing a map to make sure that what I want to do is as I test out each of the numbers when I output it here, I just want to make sure that it's mapped correctly. Because I'm multiplying by row A and B, and I stink at math. Once I get this, once I get these two right, it should be fine. Up, right. So 20. Because I'm going to remap these to the color instead of the ID. That's just up and A. And then this should be up and B. Okay. So if we're going to do up and A, and we should get 20. So let me re-enable this and up and A. Hold on. That's up and B. Gave me 12. See, this is what I'm trying to figure out right now. I just wanted to write it all out so I could see. For some reason, this button why doesn't the button value have a value 2? Oh, I'm an idiot. It should just be offset multiplied by button. No, why is it not calculating this correctly? That's only giving me 4. It's not taking into account this. So if the direction is not nil, great. If button, so that's 2. Why is it not adding it here? Offset? Why is it not? You know what we should just do? We should just make this 0. No, I don't know. Hold on, I gotta think through what I'm doing here. I'm like adding too many steps to something that should be pretty straightforward and simple. This works correctly. Now all we gotta do is let's just see if too many keyboard shortcuts I gotta remember now. Yeah, it's not registering that. It's not registering that button. Huh. Why is this, why is this not working unless it's only, let me just make sure it's not doing something stupid. No, it doesn't see this. Why is this not seeing this? Else if then button nil. But down here it sees the value. This is like the part, this is the part of the stream where like my brain starts shutting off because I've been streaming for too long and talking. Why? Oh, I know why. I'm an idiot. Because I need to have, it only works when these keys are pressed. Here's why. All right, so, whoops, I'm recording now. But that's not, it's scene 2. Oh, I know why. I need to put the, I gotta do the keyboard thing. There we go. So a button has value. What I'm confused about is the first shift was 8. Now this is 8. Something is why is my brain not working on math today? Hi. It should just be a simple offset, right? Like, what am I missing here? If we want to get to, the first value is 1. It's funny, like earlier in my head, this like all made sense of how this was going to work, and then all of a sudden I'm like blanking on the math. So that gave me to 16. So I did down and A, which gave me the same value as R. And that gave me 32, which was right in A, which is here. Which was right. Right in A is dark green, which should just be green, blue, black, and white. Green, blue, black, and white. Whoops. Green, blue, black, and white. All right, so that's right. So somewhere along the line, I'm missing something. I'm missing just. Let me try up in A. So up in A gave me 8. Why? All right, here's what I'm gonna do. I'm gonna take a quick 5-minute break. I just need to walk away from the computer and reset my brain. So I'll just let this run while I'm gone. And I'll be back at 2:15. Whoops. I gotta fix that. All right, I'm gonna take a quick break. I just need to like walk away from the computer. I can't sit here and like do this like for hours on end anymore. It's like part of getting old. So what we'll do is we'll take a quick break, and then I'll come back and I'll fix the math, and then we'll move over to the other part of what I want to do, which is I basically want to just set up. See, I can't even talk now. Look at that, man. I'm going to create a C# game from a Lua one. So all right, I'll be right back. Okay, I'm back. All right, let's see if my brain will work now. I just had a little snack. Maybe my blood sugar's going too low. So, all we need to do is count by 4. So why am I not doing this correctly? It's amazing. I could build a game framework that emulates old game consoles, but I can't count by 4. So 1, 2, 3, 4. What we need to do is take the we need to take the offset. We need to take the offset multiplied by 4, right? So that'd be 4, 8, 16. So offset multiplied by 4. So that'll get us there. Then what we need to do is add the button. Then we need to add the button offset. And what I was got to figure out from the button offset is it needs to shift it up and down in the matrix, right? So that's going to be, if no button is pressed, it's 0, which we ignore. If one button is pressed, we need to shift everything down by 4, 8, by 12. So button multiplied by 12. Did I, okay, I need to reconnect this, and there we go. See, I need to eat a snack. Right? That gets me to 28. Oh, shit, that wasn't right. Maybe I'm adding too much. Whoa, it doesn't like that at all. Too much, too big. How big was that number? What did I go to? 60. All right. Maybe it's, I think it might just be multiplied. All right, let me restart it. Left, X. So if I did left and X, actually, wait, let me redo this. We want to do up and A. Up and A is 16, which is wrong. Well, wait, up and A 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Needs to be plus, needs to be shifted up by 4. So that gets me to 20, which is correct. So now down in A should get me to 24, down in A to 24. That got me to 36. Why is my brain like shutting off? All right, maybe I might just take a step away from this and move on to something else and come back to it later. I mean, the basic concept is here. What I'm just not taking into account is I think I'm just not doing the I'm not doing the shift right. But honestly, maybe that's what it. Whoops! I hit the mic. So this is 4, 8, 12, and 16. The problem is that, let me just see something real quick here. 20 minus 4, whoops, is 16, and then 36 minus 20 is 16. This should be plus 16. So to get from here to here, we need to add, right? So 16 plus 16 is 32 plus 4. So this should be our button value multiplied by 16. So, and then plus. So left in A, whoops, is too much. How do we get back to 64? Offset button. I need to take a look at these. I need to take a look at these values. 3 multiplied by 4. 3 multiplied by 4 is 12. Right? So wait a minute, hold on. Up should be 4. 1 multiplied by 4 is 4. And then button, if we did, so then 1 multiplied by this should be 4. And in order for us to get to this, we need to add 16. So what I'm not understanding is if button value is 1, multiplied by 16 would be 16 plus 4. I see why. Because I'm increasing this I. No. Offset equals the offset, which is direction multiplied by 4, right? We don't need to read, that's why I'm duplicating it. Now all we need to do is take we've already multiplied by 4. We take the button offset multiplied by 16 and add it to the current offset. And now this should be 20. And there we go, that's 36. Yay, I did it. I'm stupid. Okay, so I'm gonna get rid of this right now, and I'm gonna get rid of this. And right now, we should be able to now do green. What I wanted to do is I want to get to the inverted state. So what was the inverted one? The reverse was right and B. So there we go. That's garish. So what's another one that we want to test out? Let's test out dark blue, which is left and A. Oh, I did right. Whoops. Here we go, dark blue. Cool. All right, so that is done. add in Game Boy Color style palette shifting on startup. Perfect. And now let's just change this to use the start key instead. So there should be a splash screen. And what do we look for? If button start equals true or button A. So let's just remove this, and the start key should be A to start. Cool. So now if we restart the game and press A, it'll restart. But if we reloaded it and held down left and X, we will now get the color shifts. Hey, that's pretty cool. I know it took me a minute. I probably lost everyone who was watching because I just couldn't do stupid math. But whoops, I don't want to. But now we can sort of shift the colors. That's cool. I can't believe that took me so long to figure out that stupid math. All right. Hey, so now we're back on track, right? So the game's done as far as like for right now. The next step of what we want to do is we're gonna convert something into C#. So let's do this. Let's save this guy out. We're going to archive it, and this is what we'll ship with the next release. I've got this, and this basically now is all open source, and I have the license and the copyright and all that other garbage in there. I've cleaned up the project. I've removed all the stuff that doesn't need to be in there, and we should be pretty good to go now. Add in spikes, add second bad guy, create more levels. Yeah, we're going to do that stuff. Add in a leaderboard, add in score rank, expose PV8, right, we'll do that next. Touch controls, add controller support, and use the start key to start the game. Cool. Wow, awesome stuff. All right, so I'm just going to close out of this for right now. And let's quit Game Creator Pro, and let's quit Photoshop right now. And we can stop the tail. So what I want to do now is we are going to port a game over to C#, a Lua game over to C#. Now, I lost my music for a second here. Let me find some new music for me to listen to. Oh wait, don't I have like a radio or something? I'll listen to my daily mix. Whatever this is. Sure, whatever. All right. So what we're gonna do now is let's go, and I have a copy here of in Documents, Projects. I should have this Unity runner. And we're going to services, open up a new terminal window. We're going to pull down all the changes that I've been working on. And then we're also going to go CD assets, streaming assets, Lua demos. We'll pull in all the Lua demos. And then print working directory, assets, CD, PixelVision SDK / no, that's what we need to do. Git pull all. There we go. Cool. So now this project should be updated. And if we open up Unity, we're going to go through and take this. Let's open up the renders, User Studio Document Projects. Let's take a look at how this works. So I wrote last week and earlier this week, I wrote a demo in C#. Oh, I wrote a Lua game that sort of showed off how. Let me open up the project correctly here. We should look at demos, scenes. And I just want to set this to the right aspect ratio. I I created a Ness Sprite Lua demo. And we're going to run this guy if Unity will compile correctly. And this is the basic demo. It's a really simple demo. All it does is it just shows how like you can use like some of the Ness sort of the tricks that the Nintendo used where you overlaid sprites to get more than 3 colors on a single sprite. We're gonna port this over to C#. And I started getting this up and running here, but we're gonna need to create all the new code. And I have it loading up the demo. We just need to start creating a new class for it. So in order to get this to work, we're going to open up the C# project in Writer. And at the same time, reveal in Finder, Unity project assets, streaming assets, Lua demos. Where is this guy? Ness Sprite demo. We're going to open up this code here. So while this guy loads up, we're going to take this project and just simply, there's not a lot to it. It shouldn't take me very long. Hopefully we'll have this done in the next hour, and that's probably when I'm going to end my stream. But we're going to turn this into a C# game. One of the things I've been doing a lot of in Pixel Vision 8 is the new Unity runner. If you like, so this is all open source. If you wanted to build your game in Unity instead of with a game creator, I've been building out different scenes. So like if we take a look at this canvas scene here, this is all running in Lua. And so you could do the drawing API. I don't know why it's running so slow. Unity's been having some trouble on my laptop lately. And then here is the same exact demo, but in C#, which you see actually runs a little bit better. So we're going to do the same thing here. We're going to create one for this Ness Sprite demo runner. And let's come in here and we're going to look at our demos, and we're going to create a new C# class, and we're going to call this Ness Sprite demo game chip. And we'll take a look at there should be another one in here that's like the empty. We'll look at the empty template just as a point of reference. And we'll copy over this stuff. And we'll copy this over too. We're going to name this Ness Sprite demo. And what we should do is come into here, and in this scene, we're going to just replace the, we're going to replace this. So we call this Ness Sprite demo game chip. And now it won't do anything, but if we'll extend, let's extend the game chip. Whoops, I need to undo the shortcut here for the arrows. We'll call this game chip and save it. And now if we run Unity, I don't think we'll get an error. It just won't do anything. It'll just give us it'll give us the pink screen, which is like the default color on this template. So now it's loading up this class. And these are just some, I mean, there's a lot of ways to write your own runner. I just give you sort of a basic example. But now that we have this done, what we can do is we're going to need to implement a few of the APIs. So let's just override init public override update. And we're going to do public override draw. And these are the main, these are basically the main methods that you have in your game anyways. For init, we actually don't need to call base, and for draw, we don't need to call base. But it's very important to call base on update, because that's how it calculates the logic it needs to get to the next frame. So long story short, like if you wanted to write a very simple game class in C sharp, this is the structure, which mirrors what we've done in C sharp. Sorry, in Lua. So let's, we're going to move this window over here. And now that we have, this resolution is killing me. It's a tiny little resolution. All right. What we're going to have to do is we're going to have to create a few classes here because this ain't going to work right. Let's take a look at something else that uses sprites, like this, the sprite stress micro platformer mouse, the tile map one. What I've done in this tile map one is I've created a, did I do this by hand? All right, well, let's go we'll take a look at what we have to do. This one, the reason why I was porting this one over on the stream is because this one's not a very straightforward one to do. We're gonna have to figure out, we're gonna have to create a lot of this logic over again. Let's just start with some basic stuff though. State, total, speed. Okay, so we'll just start by creating an int for state equals 1, an int for total states equals 3, and a float for speed, which will equal 0.08 f. So once we have those things, we can close this out. One of the things I really worked hard on for Pixel Vision 8 is that the core of it's C sharp. There's a Lua layer on top if you wanted to sketch out ideas. But the Lua APIs and the C sharp APIs are literally exactly the same. So here we can just do background color, and we're going to set this to 33, which will set the background color to a light gray, I believe. While we go through here, I'm going to delete some of this stuff that we don't use anymore. And then we need to get a reference to var display. And we're just going to call display. And this will give us a reference to the display's size. And I'm gonna copy this stuff literally word for word. In fact, what we'll do is use a following text. We combine two sets of fonts into the default. We'll copy over this, and we'll make this slashes. And there's a few things like in Lua you use local, C sharp you use var. Well, in this case it needs to be string because it's a it's going to be a private field. And I don't know if anyone else has this problem, but I can't seem to get the scroll bars to render correctly in Rider. It's like, it drives me nuts. I don't know why it's... There we go. Now it pops up. All right, so we got the text, and all we need to do is end this guy in a semicolon, and we should be good to go. So the goal of what we're going to do first, before we start getting the character animations working, is we just want to get this thing to display the text correctly. So here we can actually copy out... all right, we'll do furniture in a minute. We can copy out all this stuff directly. The formatting is going to be a little different. In Lua, comments are 2 dashes. In C sharp, they're 2 slashes. Here, we're going to change local to var. When it's in a field like this, you don't have to define the actual scope. You can use var, and it'll use inference in order to figure it out. Hey, look, again, I've lost my scrolling. There we go. So we'll do semicolon, semicolon, semicolon. Here, instead of this pound sign, which is what Lua uses in order to get the length of something, we're gonna have to type length. I'm gonna stop this Pomodoro real quick, and then we'll get back into what we were doing. The big task right now is we're just going to port to C#. All right. So we add a semicolon here. This start Y, we're going to add a semicolon as well. And let's just bring back in this. So now here's where things start getting a little weird because for loops are a little different in they're functionally similar, but let's go ahead. We're going to create a for loop, and we need this to be we're going to have to reverse it. So we're going to do whoops. This will be total. We're going to do this backwards. Total. We want basically I to be greater than 0, and then we'll do I minus minus, and we can delete this. We'll pull this line out and delete this end, and then here we're just calling draw text. And like I said, because the core APIs of PixelVision 8 are actually the same in Lua and in C#, most of these things just copy over directly like this. Now, the last thing we want to do before we just like test this out real quick is we're going to copy over this. We want to redraw the display. I'll copy over this. I don't think this text is actually like 100% accurate, but having some commenting is better than no commenting, I guess. Oh, why is it not like... No, because it's not I need a semicolon there. All right, there we go. We'll put that in here. Again, just different styles for commenting in C#. And all redraw display is going to do is it helps you. There's two things you need to do when you redraw the display. You need to clear the display and then redraw the tile map. Redraw display just combines that into a single call for you to make it just a little easier to work with. The other thing we're going to do is I want to let's also add in this this text. Again, I should just be able to do this. The only difference here being that in Lua you use 2 dots to concatenate a string. In C#, and in most other normal languages, you could just do plus. Let's move to the end here, and we'll do a semicolon, 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 semicolon. And now, if we've done this correctly, it doesn't look like there's any errors. What we're going to do is we're going to set up the basic template for the project where it just displays the text, and then it displays the text about what the demo is. It changes the background color. And we're drawing the text for the frame, the tiles per sprite, the frame rate, the state, and the speed. So let's go back to Unity and recompile. So it's telling us that something is out of index. I have a feeling, let's see, line 48. I think it has something to do with my for loop. Sometimes I mix up the for loops. Line 48. Yeah, I have a feeling like hold on, let me open up the empty template. I sort of why do I have this different? We want to render the text from the bottom of the screen up. I'm just going to copy it from here. This is the same. This should just be the same text. This will save me some time. All right, there we go. So as you can see, we now have the demo basically displaying how it was before. The only difference here is that And we should actually test this out. I should, well, I don't think I update. Oh, you know what? I need to make a bug for that. That's a, let me log a bug real quick. Where would I log that? Lua demos. I'll create an issue here. Need to update fonts to use first color. In v0.8.0, the default system. I'll use the first color for the default font.png file. Need to update each demo to reflect that and change the color offset accordingly. All right, that's an enhancement. I'll deal with that later. Enhancement. And I don't even think I set up any milestones in this project, so I'll just leave that as an issue. It's not critical. Basically what happened was I went through and I changed the fonts, the first color of the font, so that it's easier to shift. All I need to do here is I just need to figure out where that offset was. Was it 32? Right, that's black on the Nintendo. Ugh. Why is it doing that? Oh my god. Not having a horizontal scroll bar in Writer is literally driving me nuts right now. What does it say? 32? So now if we rerun this in Unity, the text at the bottom of the screen should be black. There we go. What was all those errors? There's a lot of warnings that are coming here. What are these warnings? Use the keyword if hiding is intent. Member inherit. Oh, I see what it is. Game Chip has a display. All right, I'll have to look into that. I'll look into that later. Okay. So there's a few ways that we could do this now. What I think would make the most sense is to draw the furniture stuff, and let's try to create a well, what we can do is let's add this logic for updating the frames and stuff. So we'll add this to our update, and I'll just go line by line and clean this up. Basically, that's not what I want. Edit, find, and replace. Edit, find, and replace. We're looking for then, and we're going to make that an open bracket. And end will just be a closed bracket. So what we need to do is add a semi. Why speed? Oh, I see why. Speed should actually be a float. No, it is a float. Why is that not? Type a double to type float. All right, it wants it to be a double. Sure. right, we'll make that a double, whatever. All right, so we'll do the arrow. So this is down arrow, left arrow, and let's do this. Button 1. Argument type in is not assignable parameter chips buttons. Okay, why did it work there? Maybe I can cast it? No, this should be an button. Fine. We're going to do button down arrow. So in C#, there's enums. The Lewis stuff ignores that. So we'll just do buttons. What was it? Up. Button. Left. So that's good. That's good. We'll get rid of this. This. Else. If. Something's wrong here. Unexpected token. There we go. And this is button arrow. Buttons arrow right. All right, so now what we've done is we just moved over the logic where in the demo we were able to hit like up and down in order to slow the speed or increase the speed, and left and right will just cycle through the different animation states. So, oops, I had to like crack my back. So now if I hit up and down, you see the speed is decreasing and increasing. And if I hit left and right, that works. I don't know why speed went like that. I can fix that later. But now I can go through the states. Okay, so this is critical for when we want to go through and demo what's actually going on with the sprites. So next on our list, what we're going to have to do is we're going to have to by hand create the SB sprites thing here. It should be like SB sprites Lua. Right? These are all of the sprites. Now, I can't remember if I did this in another demo. I might not actually have another demo that has a lot of sprites in it. This one's a more complicated one. Empty template, font, micro platformer, mouse, music, nest, screen wrap. Let me see what I did in the screen wrap demo. I think for each of these guys, I just define them as classes. Block sprite, that shouldn't have it. And the tile map. Yeah, I created individual skeletons. Read only. Oh, here we go. Come on, scroll. Sprite data, that's what I was looking for. Okay, so we're going to create variables for this stuff, and we're going to we'll pull one of these out as an example. So here, if we go to our nest demo, we're going to create a read-only sprite for each of these pieces of furniture. And we'll import this missing reference, which should just be part of PixelVision 8 SDK chips or demos. Yeah, it's just demos. It's part of the demos namespace. And let's duplicate this. So there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I created this sprite data class in the demos. And it just basically mirrors this stuff. It just shows you like the total sprites, unique, and all that stuff. I don't think the total and unique is used anymore. Right? Yeah, we could probably get rid of this. Hold on, let me refactor, change signature. We can get rid of total and unique. That might break a whole bunch of stuff. We'll hold off on that. So here's the dresser medium, dresser small, furniture table, and we'll do the furniture TV. Now, all we need to do is just basically fill in the blanks. So, yeah, I want to get rid of this unique stuff. This is because the new sprite builder doesn't even use any of that stuff. Sprite data, refactor, change signature. We're going to get rid of unique. And all we need is the width and the sprite IDs. I don't think we use any of that other stuff anywhere else. So next, hopefully that'll delete it from everywhere else. We may have some errors we need to fix. And let's just pull this out. I'm trying to make these classes as basically as simple as possible. Let's get rid of, I don't even know what the hell that is. Before we go any further though, let's save this, and I just want to make sure I didn't break all the other demos. All right, we can hide the warnings. I just want to take a quick run through some of these and just make sure that, well, there's only one that really uses it. Let's take a look. Should be the tile map C# runner. All right, nothing's broken. It's good enough for me. I'll run through these all on my own. You don't need to see me run through all these. All right, so now what we're going to do is let's get the furniture running. Why is it running so slow today? I don't know. There's like something like wacky with my laptop. Like, that should run at like full 60 frames. I'm not even rendering anything. So Unity is just like having some sort of overhead. And I'm not sure what that overhead is. All right. That being said, what we can do now is all we got to do is copy over these values. So here's the first set of arrays, and this guy was 4. Let's spread this out a little bit more so we can see what we're doing here. This was 4. So you see, I mean, for the most part, it doesn't take too long to port over a Lua game. I mean, I did this by design. Like the biggest challenge, obviously, is just going from the unique part of C# to Lua, or from Lua to C#. But once you get that handle on that, it's pretty straightforward. The hardest part you'll see is like when we start redoing the animation classes, because those were like these like sort of like pseudo Lua classes that I created. We're just gonna have to like restructure them a little bit. Let's see, width 2, and we're gonna simplify it. Since this is just a demo, we don't need to like boil the ocean. All right, so we now have each of the furniture. Let's go through and we're gonna draw these pieces of furniture. So I believe we had like a loop here. I built some sort of like array of the different types of furniture, and then we looped through it. So in this case, we could do this down here. We'll change this to a comment, and we're going to do var furniture, and this is going to equal new array, and it's going to be a sprite data array. And then that'll get a reference to each of these fields that we have here. So we can do var next column equals 1, We'll just do a new for loop. And we'll do furniture length, or whoops. And then at the end here, we'll remove end. We'll make this a close bracket, var, item. And we just need to add our semicolons, and we should be good to go. So now if we run this, we should be able to see all the sprites that make up the furniture because we're drawing them into the background. Bingo. See how easy that was? Again, a lot of this is pretty straightforward. This is going to be the tricky part right here, which is we're going to have to create some classes that represent each of these type of entities, and I'm going to simplify things a little bit here, and I probably will simplify it in the Lua code too. When I was building this demo out originally, I wanted it to be, I made it a little bit more complicated. Here's the entity stuff. What I'm probably going to wind up doing is just create a generic created animated entity, and then we'll just customize it with the unique player stuff. So up here, I'm going to create some new classes. We're going to do a public, we'll call it an animated entity. Right, and it has a int x, oops. I should have made this class. And we'll create we just create a constructor here. And in the constructor, we're going to do int x, int y, int w, int h, int color offset. And then a float delay. I think I've actually wanted a double. Right? And then now, I think I sort of did this backwards. I bet you if I would have just done int y, int w, int h, int color offset, double, what was that last one? Delay. And actually, let's make all these public because I think we referenced them. Public. Now we can just do this. So this dot x equals x. Actually, I think if I just redo this constructor and let writer generate it, it'll just do it for us. Generate code. Yeah, here we can select all of this stuff. Bam. Okay, cool. Now I have to retype all that crap. So that's going to be the constructor for our animated entity. The other thing that I want to do with the animated entity was there is a draw animated entity and a update animated entity. So we're going to call public void update and pass it in float time delta time, and we'll do public void draw trying to see real quick if I need to we might just need to make this a method down here where we can update all the values here, but when it comes to drawing it, we probably are going to have to make the function down here. So we do public void draw animated entity. we need to make this a public class. We'll probably switch this around. I'm just trying to like do a big sweeping, like sort of like block out where the logic needs to go from Lua, and then we'll tighten it up, and then we'll make the Lua example sort of match this a little closer too. And then here, this is pretty straightforward. We can actually literally copy this stuff straight out of here. And if target does not equal null, then and we'll have to add a few other. We have to add a few more properties to this thing. Where is end? I hate when it wraps. Like between the low resolution and the wrapping, it's like it's so hard to do any. It's like hard to code at this resolution. All right, so did this. If this does not equal null. So let's, we're going to add two variables here, basically. I believe these are going to be just arrays of ints. We're going to add this to our animated class. So we'll do public int equals we'll just leave it as this. When we build the other classes that extend it, then we will implement it. So what we're doing when we go to draw this stuff is that we're testing to see if these values have been set, and if so, we draw them. We also need some overlay values, which should be just a vector. So we'll add this into our animated class. Vector. This is the big problem with C# is that, you know, unlike in Lua, so when you're writing a game in Lua, you don't even have to like really define the variables. You can just like leave things as null. You can throw stuff basically wherever you want. What we have to do now is make sure that we clearly define them ahead of time. Like in this case, this needs to be public. What else is it missing? I would love to scroll to the right, but the scroll bar doesn't show up. Overlay offset W. All right, so I need to make a new class. This sort of stinks. I probably can make a strut, but we'll just do this. Public class overlay we'll just have it extend vector. And then we'll add a construct. We need a int for come on. So annoying. Offset W. It's just a vector with a W. We could probably use a rect, honestly. Let me do that. And then I'll have the width and the height, and then all we need to do down here is we'll just make this width instead. Jeez. There we go. What else is missing? Right, and then we need a semicolon. So that should be the high level stuff that we need in order to get the basic animation system running. Now all we need to do, we didn't port over the update stuff. Let me do that, and then I will I'll do that, and then when I'm done with that, we will I'm gonna take a quick 5-minute break. I just gotta stretch, and we should be good to go. So in the old system we did we made it, you know what, let's we'll follow it how it was here. We're just going to make it part of the class, the game class, and what we'll do is we'll pass in a animated entity called target, and we'll just do it this way. This way everything will sort of work over, and then we just need to now fix the rest of these things here. We'll call this time delta so it matches up. In this case here, we'll set this to here, this to here. Everything gets sort of screwed up until you wind up doing the until you wind up figuring out the right formatting. Yeah, we're missing like all of these things here. So we need a frame time. Where do I define all this stuff? All right, let's go and add this stuff into our animated class. We'll make this public. So some of this stuff, like this, is going to be float. And that's actually the frame delay, so equals 0.8. I think we need to make this a float. Actually, we'll get rid of the delay. We'll leave this as is, as a float. The current frame should be an int, and the frame time is going to be a float. And then we're the other thing we're going to get sort of, it's going to bite us in the butt is all the animation stuff was set to an index of 1. We're going to have to account for that. That's the other challenge in importing over from Lua to C# is dealing with the offset. So what I just want to do, so I do need to take a quick break. What I don't have here are frames. Frames is an array of ints. And I think it's going to be a public int frames. We'll see if this works. C# arrays for like to this day still like current state. And we need a public int current state. To this day, they sort of mess me up. Parameter is invoked has... I don't know. I'll have to look into that. I still get confused by like nested arrays. I might have to just look at another example of how I did this in the past. Does not equal null. But we're pretty close. Overlay frames. I don't know why overlay frames is... All right. Okay. We need to copy this too. There's a lot of... Man, there's a lot of code in this. I mean, I imagine porting a full game would be a little time consuming. That's why either you start in C# or, you know, like I said, the Lua stuff's really do... Like if I was to port... well, let me finish this up and then we can do talkie time. Target. Where is target defined below? So somewhere along the lines here, this stuff isn't matching up correctly. All right, that should fix that, and then all we got to do is just figure out the right. Oh, you know, let's just make these frames. This should be a jagged array. All right, then that fixed the jagged array. All we need to do now is the jagged array is going to, it's not they're not ints, they're actually sprite data. I mean, I think I'm making this look easy. I just know, I'm just sprite data. I've just done this enough that I sort of know. One day, people will be able to use Pixel Vision 8 on their own without, like, the fact. I mean, I've been doing this for 2 years, so I'm pretty good at this framework now. Luckily, you don't have all the bloat that I have in my head of all the stuff that used to be in there. All right, let me. I'm just going to go and run this real quick. It's not going to do anything more than what we had before. I just want to make sure it doesn't like just throw any like really stupid errors. All right, there we go. So we're displaying our furniture. We got our text, and we got our frames per second. We also got our input working, so we can change different states and we can do the speed. So I'm going to take a quick 5-minute break, and then we're going to spend the last 25-minute Pomodoro of porting over the animation stuff, which shouldn't be too hard at this point. So let's close this out, and the task that we have been working on is porting this to C#. So it's 317. So let's just say like 320, 18. Yeah, 323. I'll be right back. So while I was finished taking a break and sort of stretching, so what we're gonna do now is it shouldn't be too hard to port over all this animation stuff. I think a big part of it's just gonna be copying over all the sprite data that we need to do. So maybe what we'll do is we'll block off a region. We'll move over the sprite stuff. We'll create the classes for each of the different entities, and then we should be pretty much done. This isn't a terribly complicated code example. If you are just tuning in, basically what we're doing is we're taking this code example, which I wrote last week, which just shows how to do some like more advanced like Nintendo style sprites, and we're going to we're porting this Lua demo over to C#. So where we are right now is here. And we're going to go and we just got to do the, now we're doing the more complicated part, which is getting the animation engine running. So the animation stuff, I just wrote this all by hand. It's very easy to do. It's very simple animation states. What I want to do now is I want to see if there's a way that I could just copy all of these sprites over. And let's see if there's a way that we can, by using find and replace, make them a little bit, but just by using find and replace, see if there's a way that we can simplify this. Actually, before we even dive into this, what I think we're gonna do is, I think we'll just do that per thing. Let's see here. What do we want to do? Okay, let's just create the guy and see if we can get him working, and then that'll give us a better idea of what we're doing here. So if we go and we create this guy entity, let's go into C# here, and we're going to create a, whoops, I just jumped somewhere. So public class guy entity. And so this is our guy entity. He has 3 properties, but more importantly, he's going to extend oh, boo. We're gonna have to make some modifications to this. It's just, there's some like strange, well, they're not really strange, but there's just some uniqueness to how C# constructors work, and we're gonna need to work around this. So let's set this up as an animated entity. The problem we have is that in the constructor, we're not going to be able to pass in this stuff like this. So what we want is we only want to pass in X, Y, and color offset. We're going to have to do everything else by hand. So I'm going to modify the animated entity. Let's refactor and let's change the signature. We're going to get rid of the width, the height. We'll leave color offset and we'll leave delay as optional. Actually, I'm going to remove delay completely. Basically, I'm just moving away from what's going to wind up happening is you're just going to have to configure this by hand. 0.08 offset frame delay equals 0.8 F. Get rid of that and this, and let's rebuild this guy's constructor. So here, now all the guy needs is an X, a Y, and this. And then in the constructor, we will go ahead and we will set the width and the height and the stuff like that, right? Because 3 and 4, the color offset. So his width is going to be 3. His height is going to be 4. And then we're going to do our best to recreate all this stuff. I just got to remember how to do the nested. I just got to figure out how to do the nested things. So let's paste this down and we'll just take a look. We don't need the data scope because this is now its own class instead of how we were passing around tables before. And the current state will be set to 1. These are the frames. We're going to do a new sprite data array. And what's happening is that these guys don't exist. So let's try to copy over. This is where things start getting a little sloppy. If you bear with me, we'll get this we'll figure it out. We just got to guy. We're gonna create all of these as fields on the guy itself instead of making it global like we sort of had with the Lewis side. We're gonna have to just do this. So this is private read only sprite data. All right, and then the next thing we need to do is we're going to replace this, which is where's find and replace. How did new sprite data? So it should equal new sprite data. And what we want to do is make sure that this stuff is, we're replacing only the selection. In selection, replace all. So now we're creating all of these new sprite datas. And now what we need to do is we can replace sprite IDs with a new keyword. So let's copy this and we'll replace sprite IDs with new. I think we can just do a new bracket array. Yeah, new brackets. And that's the shortcut for doing that'll be the shortcut for doing in selection replace all. That should be the shortcut for creating a new array in here. Now, the biggest thing with the problem we're seeing is I believe if we just add a semicolon, nope. What we need to do at the end of this is we're going to change these double brackets at the end into a bracket, close parentheses, semicolon. And reselect this. I had thought about actually I could write a very basic parser to convert this stuff. Hey, look at that. All of it works now. Jump one, jump. So now what we need to do is get this stuff working. I just don't remember. I think we need to do new. Sure, why not? I don't know why. Like, there's just something about the way that like nested, like jagged arrays and C# work. Like my brain just doesn't like it. All right, overlay offset. So for the overlay offset, we're going to create, I changed this to a rect, and we'll make this 8. So that sets that, and then the overlay frames, we're going to set to new sprite data jagged array, and we'll make this new. Let's see if this works. I mean, it's going to compile, so that's something. Let's save it and let's rerun it and see what we can get. All right. So what we need to test out is, can we actually get something to render? Now, here we created a guy entity. So let's go into our class here and underneath the message, we're going to create a new private guy entity, and we're going to just call it guy entity, and make a new guy entity, and his position is going to be 8 by 8. Oh, I want to set the default color offset value to equal 0. Guy entity value equals 0, and we should be good. So that's going to create a new guy, and then now all we need to do is we'll start it with update, and we'll just see how this works. But we're going to call update animated entity guy and pass in the time delta in our update loop. Draw. All right, that's the first step. Where was he? Right here. All right, so fingers crossed. I mean, the one thing I do love about C#, outside of I do love the language a lot, is that the compiler tells us right away if something stupid is happening. All right, index out of range. So my thinking of that is state should equal 0. I have a feeling like we're going to run into some array issues because of the way the Lua is 0 based indexed. All right, well, it's running, so that's something. Let's take a look at the update and see where we're getting into the problem here. So, sprite IDs, target frame, current state, current frame. Okay, what we need to update here is that the current frame is going to equal 0. And if this is greater than or equal to this, we were going to reset it to 0. We also want to make sure that the current frame starts at 0, which should be good. And let's try running this again. There we go. So you can't see it, but it's not throwing an error, which means that our arrays are working correctly. So now all we need to do, hopefully, is draw this guy. Come on, we can do it. Redraw display. Okay, let's go. Hey, look at that. It works. It's off, but it works. Now, all right, let's do this. Let's get the girl working. Well, no, let's just fix everything. So the state should be set to 0, and the current state should be set to 0 here as well. And what we just need to make sure is that when we loop through this state, that current state minus 1, it should stay clamped between 0 and 2. 0 and 2. Again, we have to re-offset it because of that the way that arrays are handled. But now what we can do is this. Let's just copy this stuff over. We haven't brought the other guys over yet, but I'm just going to mask them. I'll just comment them out. So frame delay equals speed. And speed, I think I set it to a double. It should actually be a float. Whoops. Let's see here. FLOT. All right. And we just got to make sure that we fix this. This is an F and this is an F. And let this recompile. And now we should be able to look at that. We can speed it up. We can slow it down. It's interesting that it does that. I bet you if we made speed a double, we wouldn't get those like that kind of stuff. But that's fine. It's just, you know what? It works. And that's all that really matters. That's all that matters at this point. What I want to do now is let's just build out the girl and the, actually, I think I'm going to start with a zombie real quick. Nah, we can do the girl. The girl should be pretty straightforward. All we need to do is copy the guy. And then we're going to replace wherever we see guy with girl. Because it should just be the same thing. We need to just go here and now find and replace guy with girl. We want to match the case. And in selection, all right, let's replace all. Girl entity, we're good to go. And now we should be able to create a girl entity. And she was set up at 32. What was this offset? Oh, that was the color. Right, that was the color offset to 8. Oops, girl. And then where we call update here, we'll just duplicate this, put the girl here. We'll enable the girl. Yeah, this didn't actually take that long. I mean, I mean, it helps for me because I really understand one, I understand the framework, and then two, I understand how to convert stuff from C# to Lua. Well, this compositor, it's hard to say. I wonder if my... Nope. I was looking to see if my family's back. All right, cool. So those work. All right, so these guys work. We can now do the shifting between the different frames. We can change the speed. They should both be in sync. And we're good to go. The last thing we need to do now is just build out the zombie. And I'm pretty sure that that's going to be... I think it's going to be very similar. Let's just try copying over the girl and just renaming it to zombie and see where we get, and I'll just double check everything here. Oh, you know what we got to do? The girl one was a little bit different. I just remembered. Her offsets are a little different. I believe 3, 4, that's the same. This stuff's the same. It's her offset. Her overlay offset is 881. 881. Maybe it's the zombie. Yeah, his is okay. His is different. All right, so let's copy the girl. And I think I know which ones I need to delete in order to make it a zombie. Girl. So, actually, it looks like we can simplify this in this right here. Whoops. We don't need the other ones. We just need the zombie running. But his overlay, whoops, where's the zombie? Create girl, create zombie. 881. No, the girl is 083. Girl. 083. Girl overlay. Now the zombie doesn't have an idle. Doesn't have any of these idles or jump. All the zombie has is the running overlays. You know what I need to do? I think all the overlay stuff is wrong for the girl. All right, we'll fix that in a second. Maybe it's wrong for the zombie too. All right, we'll look into that in a minute. But I wanted to see if we can just get this zombie working. He should just have zombie. Yeah, we don't need this. We just need zombie running and zombie run overlay. 881, 881. Current state 0, which is fine. 3, 4. In fact, we can get rid of this. We can get rid of this. I just want to clean up the C# code. I mean, eventually, like over time, I'm gonna go through these demos and like really comment them up very well and stuff like that. My plan is to eventually write tutorials that help you rebuild the demos, so you can either just play the demos or whatnot. But all these are the basis of like little games that I've been building, and that's really the key to what I wanted to do with PixelVision 8. Is like I got a whole bunch of little games I want to build and some stuff I want to show off for Amazon's new services, and I'm just gonna build up like all these little like micro games to sort of show off. Here's a very basic game, but then here's how the service is implemented, so you don't have to focus so much on these like large complex games. So zombie entity. Nest sprite demo. All right, so let's add the zombie, and then we'll fix the girl's animation stuff, because that's probably going to be broken now. All right, he's 56.8. Zombie entity 56.8 and 8. Sure. Right? Really? All right. Whatever. I'm sure the color offsets are wrong. I didn't really clean this up in a way that made it work. All right, and then I just need to now here. Let's just duplicate this and do zombie entity. We will set the zombie entity for speed, and then we'll draw a zombie entity. I believe it's going to break. The girl's animation is going to be broken because I changed the overlay stuff. That's probably going to throw an error real quick. Nope. Zombie entity. Did I not create a new zombie? Here we go. Girl. Entity. I don't know what that auto-completed to. Zombie entity. There we go. All right, so this might just throw an error. We're gonna fix the girl's animation stuff. Yeah, oh, it doesn't throw an error, but at least it just shows. You can sort of see. Here, I'll zoom this in so you can see a little better. You can see her overlay is completely off because we don't have all the right sprites. And why is the second one still showing a girl? Right. Okay, we need to... I thought I was being clever by copying all this stuff over, but the problem is that's not going to actually work because they're all different values. let's try doing it this way. We'll start with just the zombie. And we need to change this to new sprite data parenthesis. Then sprite ID needs to change to new. And then the last two curly brackets will be a curly bracket, a parenthesis, and a semicolon. And we'll replace all. And that should fix the zombie. Again, what was happening is because I copied and pasted, it was basically just showing you it was just showing you the wrong things. There we go. The zombie now works. Although the zombie has the wrong colors. It has the girl's colors. All right. Well, we can fix that another time. Then what we want to do is we're gonna do the same exact thing for the girl, and then we're done. So let's copy this and oh, it's slowing down. It doesn't like this large of a selection. All right, so we'll just start with where we were before. We need to change width to new sprite builder. Whoops. Let's select all this stuff. Ugh, I hate when it does that. I got to figure out, I don't know where. Oops, I don't want sprite builder. It should be sprite data. I need to figure out where to disable that feature in ReSharper because it's driving me nuts where it automatically wraps the text. New array. All right, cool. So now all the girls' animations are there. And if we rerun this, there we go. So we've now ported the whole thing over to C#. That wasn't too bad. That was only like an hour and a half of work, maybe an hour, 2 hours worth of work. Let's go and take a look at the Lua one. And it should be the same. The only difference is that for some reason the zombie is not at the right. Let me see if I may have I think when I created the zombie, yeah, okay, 0, that's what it is. The zombie's color offset should just be 0. So leave this off and rerun it. And now we have exactly the same. So that's done. And the cool thing is that all the demos are now done for the next release. This is all good. I can now start building. My next plan is to really build this into an actual game. And then we're going to add in a game on to it so that we can have some... we're going to make a sort of a Nintendo esports game, which I think would be kind of fun. Cool. All right. Well, that being said, I'm going to save all this stuff. I'm going to stop the Pomodoro timer, and we're in a good shape. Let's stop the countdown Pomodoro timer, and I'm just gonna commit all this stuff before I quit. And let's see, Unity Runner will open up a new terminal window, and let's do this. Git add all. We need to go into assets, streaming assets first, / Lua demos, git status. What did we change? Oh, I deleted some stuff. Git add all, git commit, and cleaned up nest sprite code. All right, git status, git push. So we'll just add all these changes. That Lua demos is in a submodule, so I have to update that first. So git status, everything is committed. Git commit, and we have added C# nest sprite demo. Cool. All right, all of our stuff is done. We have all of our demos. We now have C# version of them. This is looking pretty good, and I'm done for the day. That is my stream. So thanks everyone for watching, and see you guys another time. I think I'll be back tomorrow morning, so we'll give it a try then. So thanks. Talk to you guys later.